Welcome back to the ARSET training, transforming Earth observation data into building infrastructure data sets for disaster risk modeling. My name is Brock Blevins, and I'm an ARSET trainer based at NASA's Goddard Space Flight Center in Greenbelt, Maryland. It is a pleasure to welcome you all to the second part of this three-part webinar series. So a quick recap of this training and why we're here. Why is climate risk assessment important? So even with the drastic reduction in carbon emissions, short and medium-term impacts are inevitable. Climate change impacts and risks are becoming increasingly complex and difficult to manage. Climate change impacts on human infrastructure are not well understood and can vary drastically by location. So understanding community-specific risks to climate change is critical to evaluating adaptation strategies. So here we are in part 2, where we're going to talk about the development of site-specific exposure data with Earth observations. It will once again be a 2-hour part with presentations and a question and answer session at the end. All materials and recordings from each session are available on the training webpage, and there'll be one homework assignment which will be posted on October 10th, and will have a due date of October 24th. A certificate of completion will be awarded to those who attend all live parts and complete the homework assignment by the given due date. A little bit on the prerequisites. We talked about having an idea of the fundamentals of remote sensing, basics of GIS and databases, but also the basics on statistics and sampling. Links to each of these trainings are provided, and we encourage you to go through them to familiarize yourself with the content related to this training. Please put your questions in the questions box and we'll address them at the end of the webinar. Feel free to enter your questions as we go, and we'll try to address all questions during the Q&A session. The remainder of the questions will be answered in the Q&A document, which will be posted to the training webpage about a week after the training. So without further ado, I will introduce you to our trainers today. We have Greg Yetman, Associate Director for Geospatial Applications at CSUN at Columbia University, and Taylor Hauser, Geospatial Data Analyst at Oak Ridge National Laboratory. Greg, you're up first. Thank you very much.
Thanks very much, Brock. It's a pleasure to be here today to talk to you about, first off, working with data to merge building footprints with infrastructure data sets to improve infrastructure data sets for use in HAZUS, the Hazards US package for flood impact analysis. Yeah, so the objectives of this lesson today are to be able to understand the techniques for attributing infrastructure, that is assigning attributes on building details to infrastructure data. Identify issues in this attribute transfer. Specifically, we're going to talk about issues that arise because different spatial models and the difference in locational precision between data sets. Select the right strategies for transferring your attributes, and just by way of how we're talking about different possible sources of data, you should be able to identify common sources of infrastructure data and building footprints. So in 2012, New York State and New York Metro were rocked by Superstorm Sandy. It was a large storm, large hurricane that hit, and you can see some of the photos of flooding and damage across the bottom. And there was a lot of examination of, was New York State, New York City, different agencies prepared for this kind of storm? If this kind of storm hits again in the future, what could we do differently? And what data, key for today, what data are needed for the next storm? What would be really useful for preparation? And it was noted that risk assessment requires more than just population data and building locations, but you need information on vulnerability, building characteristics, population vulnerability as well, although we won't talk about that today. But both are really important for understanding risk and potential impacts. So prior knowledge, some things I'm assuming you know at least a little bit about today would be the basics of geographic information systems. That is that GIS is used to maintain and query spatial data, and it lets you do spatial analysis, that is overlay different layers in, primarily today we're talking about vector space, so where you can overlay layers like building footprints with other layers, tax parcels, or critical infrastructure data, and establish relationships as in which building is inside which parcel or which critical infrastructure point location is closest to which building. And GIS enables all of this. The fundamental nature of vector GIS space is a simple data model of points, which is just a XY coordinate pair for every single point. Lines, which are ordered series of XY coordinate pairs. And points are, of course, have no dimension. They're no area, no length. Lines have a length, but no area. They're one-dimensional. And then polygons, like tax parcels or building footprints. You've got a closed series of XY coordinate pairs. And the other key power of GIS is how individual geographic objects, like shown here on the bottom right, the building footprint, are linked to database records. And so on the right, you see this table of the county, municipality, the source of the data, and the roof type, 0 being flat, and the occupancy class, or how the building's used. This is educational class 2. In fact, this is the office building where Juan and I work. This is the building on the campus where we work. So GIS lets you do that kind of query and look up within layers and across layers, which makes it really powerful. And we'll see an example of GIS analysis for transferring attributes from one source to another. So our flood impact analysis, we're using HAZUS, or actually the algorithm from HAZUS, which is short for Hazards US, Hazards United States. And it's an extension to GIS software that lets you do impact analysis for multiple hazards. And in this project, we did it for flood impact analysis. So for flood impact analysis, you need to know the flood depth under different scenarios. This is typically used for planning or preparation, not for post-disaster response. So the flood depths are hypothetical or built on data under different scenarios. And we'll talk a little bit more about the flood scenarios in a bit. And then for your buildings, you need to know information about them, attributes about them, their value, the amount of money the building itself is valued at. The occupancy class, that is it residential, people live there, industrial production, commercial or retail, or commercial also includes service like office buildings, or a mixed use case where you, for instance, have ground floor retail with residential buildings over top. And then institutional, which can be anything from schools through hospitals through churches. And typically, or actually as a requirement for HAZUS, these classes are broken down further. I haven't listed them all here, but residential, for example, goes from residential 1 through residential 9. So 9 different subcategories of residential, things like whether it's an apartment block or a single family home, detached, semi-detached, all those characteristics are in those residential categories. Commercial and industrial are divided into 3 different categories as well. And the institutional is typically sourced by type, a church or a hospital or a school or a university, that sort of thing. And then key for damage during a flood is what's known as the ground floor or first floor elevation. That is not just the elevation of the land at the foundation of the building, but more importantly, what's the lowest point where water can enter? So the sill on a door, how far above ground level is that? Or a windowsill close to ground level or below ground level? Those are key points, or garage door entryway. Those entryways are places where water gets in and causes damage during flooding. So knowing the height or approximate height of that is key for estimating damages. And then critical infrastructure data. So critical infrastructure includes not just buildings, but power plants, power transmission lines, lifelines like key highways. All these things can be analyzed with HAZUS to get an idea of what could be interruptions to service during a flood or other disaster. And today we're going to focus in on the building exposure and attribute in buildings and the building damages, But we also talk about critical infrastructure and transferring information from critical infrastructure from point sources like address lookups to the building footprints. And finally, the flood data we're using in this project are two different sources. We've got FEMA, the U.S. Federal Emergency Management Agency flood data that's modeled, and flood data that was modeled by Stevens Institute for coastal flooding along the Hudson River areas that flood due to storm surge. So key for today is talking about how we compiled this statewide building footprint database. So in New York State, a number of municipalities and counties had building footprint databases, but there was no building footprint